This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there, welcome to a new episode of the Industrial AI podcast. My name is Peter Seeberg and I'm your host. Today I'm going to be talking to Andreas de Jonge, founder and managing director. Andreas and I will talk about inline AI for real industrial systems. Hello, Andreas.
Hello, Peter. Nice to be here.
Andreas, please introduce yourself to our listeners.
Yeah, my name is Andreas de Jonge. I'm a physicist. I specialized in AI about 2008, 2009. I worked in research first, then I switched to industry. And then the journey continued to embedded AI and industrial applications. And when I had the idea to found a company, because what I saw is that you have a lot of applications for AI in industry, where the data is produced, but there are hardly any solutions which fits industrial needs. And that is exactly where my company steps in. So we are sitting directly on the edge between information technology and operational technology.
That sounds great. That's exactly the topic we deal with here at our Industrial AI podcast. Started as a physicist. Your name sounds to me, being a Dutch guy, as a Dutch name. Is that correct? Or
Exactly. My family has Dutch roots.
Okay, there you go. And I think if we translate it for the English listeners, it would mean something like the young person, or the young. Is that right?
Something like that, the youngers.
Right. Very good. You already gave a quick introduction, maybe 1, 2, 3 things more, unless you have said everything about your company, just to get a feeling for on the basis of what you just explained us already about your company.
Yeah, we started as a pure software company. And what we are focusing on in the past was developing AI algorithms which really reflect the customer's processes. So in the past, I made the experience that a lot of companies try to adapt to some kind of standard AI model and try to use the standard AI model that it somehow fits to their processes. But that works quite well up to 80%. But as you know, in industry, we don't need 80%. We need 99%. And
100%.
or 99.9, 100% is desirable, of course. And on the other hand, if you look at the industrial landscape, especially in Europe, we got companies which are more than 100 years old, which means these companies, they are highly specialized. They have a deep knowledge about what they are doing. And we cannot use AI models which deliver about 90% accuracy if you want to measure it in accuracy. What we need AI models which fit exactly to the knowledge base of the customer. And that's where we started. So we started with the development of very specialized AI models and ended up in having AI models which are very small and very effective with a quite high robustness. So, for example, the smallest AI model we developed so far had the size of about 10 kilobytes, a completely functional AI model. So that's where my customers always ask twice about my AI model, 10 kilobytes, because most people connect AI with the usage of a lot of resources, big AI models. You need servers, you need GPUs, whatsoever. But if you break it down to an industrial production line, you just want to work the AI model with the data which is produced in a production line.
Very good. You already jumped into what I believe is the USP of your company. Very good. But we will come back to that a little bit later on. But very good as an introduction, so our listeners know and understand the direction we're moving. Tell us a little bit about the markets then? You already talked about companies, which I assume are then your potential customers. So what are they? What are those potential customers, and what are the markets that you or that they work in?
So the markets are, as you can imagine, that we are tailoring AI models. We can serve a lot of markets. So one of the customers I talked about was in the food sector. So it was in the quality inspection of potato chips. You can see that also on our web page. Another market is, of course, industry and manufacturing. So every production line which has some kind of sensors can be equipped with our AI, basically. And of course, we're also in the security and surveillance sector.
Right. Now, my understanding, reading on your website, and we're going to move into a couple of use cases just in a moment, is that you were selling to an in-between, like an automator or a camera manufacturer or AUI manufacturer, and at those companies. So if we move maybe to, and then later on we talk about in detail about checking the quality of food, would you sell that solution to that end line user directly, or would you sell it to an in-between company who will then make sure that their customer gets the solution?
Yeah, basically we serve these two streams. We also sell to the end customer, and we also sell you called it in between customer as a OEM product, for example.
Yeah. Okay, why don't we stay with 1, 2, 3 use cases? You mentioned the one, I think it's a potato chip quality testing. Why don't you explain us a little bit more about that? What is it all about, and what is the solution that they get from you?
So in that case, it was about testing the quality of potato chips, and the testing was quite easy. It was a binary test, good, bad, as you have it very often in industry. But the rule-based system, which was used before, was not very reliable. You see, it's a natural product. You always have some differences in the color, in the shape. And on the other hand, it's a mass product. So we need to have an algorithm which is very fast and very reliable. But it has to produce a very small output, true or false. And in that case, we were able to design an algorithm which could be implemented on a single chip on a FPGA. I think it's okay if I talk about FPGAs in that podcast, or should I explain them?
No, that's okay. We talked about field programmable gate arrays in the past,
Okay.
I think with AMD at that time. So those of you that are not knowledgeable, but you can say 2 words about why you use an FPGA. Maybe that is interesting.
Because the FPGA is, in my point of view, a perfect platform for AI. It has a very high level of parallelism, and it is flexible. So you can exchange the algorithm you're using quite easily, and it is energy efficient. And in that use case we're talking about with the quality inspection of potato chips, we were able to design an algorithm which made more than 1,000 frames per second.
Mm-hmm. Very good. Yeah. So as the acronym says, the FP, the field programmable, right? So you would install a solution, and maybe if necessary sometime later, maybe we talk about drift or robustness later, you could make an update, and in the field you could then install the update, right?
Exactly. Yeah.
Mm-hmm. Okay, let's take a second one. I think there was one detection unmanned aircraft I saw, or there's another one about manufacturing. Maybe you want to talk about that one, so we have just two separate ideas, and maybe see what it is that you typically do.
Let's talk about the UAV detection use case. So what you see in this sector, there's you have a very high or a very big installed base of cameras which have some computational power.
You may want to explain what the acronym stands for, UAV.
Okay, I'm sorry. It's an unmanned aerial vehicle, which means drones. And of course, in the infrastructure of airports or power plants, you already have an installed base of surveillance cameras. And these cameras either come with some computational power, or these cameras are connected to some kind of server where you can use some computational power. So the idea was here to equip the installed base with a very robust detection algorithm for these UAVs. That was the main idea of the use case. And we are talking about security systems here. So you cannot use some cloud connection to a hyperscaler, run your AI model, get the results back, and process the results. So it has to run on-site, which means we were using the resources we got on-site. So we designed an AI model which had about in size 2 megabytes and which runs on commercial CPU-based hardware. And in that case, it runs with 60 frames per second, which exactly matches the camera frame rate.
Okay, and in that case, you again would sell the complete solution to, for example, an airport, or is there an in-between company?
In that case, we are selling to an in-between company.
Okay, good. Okay, yeah, the second one is a topic that we hear about almost daily. It's a little bit on the side of the industrial, but it's very good to know that in addition to the industrial capabilities of which we heard about, one, you can take care of this use case as well. Now, in your introduction, you already jumped into, and that was very good, into what I believe, if I'm going to ask you what your USP is, but maybe you tell us again yourself, and maybe the listener could already get a feeling themselves out of the use cases that you presented.
So our USP is that we are able to reproduce on the software side or on the AI side, you're able to reproduce a customer's process in the architecture of the artificial intelligence or of the AI model. And that is a huge advantage if it comes to robustness, to transparency, and to efficiency. That is what we are doing on the software side. And in the past, we always experienced that actually, in many cases, developing the AI model is not the real bottleneck. The real bottleneck is very often the integration of the AI model in the customer's processes. So if we find some platform where we can integrate AI, we are quite happy. But as I mentioned before, we got companies which are about 100 years old, and they have production lines which are about 10, 20 years old. These production lines have some kind of sensors, and these sensors produce actually gold. The data these sensors are producing is very, very valuable to us and to the customer. And the bottleneck here is, how do you integrate AI in such a production line? It's called brownfield integration. And normally you try to connect these sensors to some kind of OT, IT gateway. You send the data to a server or to a cloud server, whatever. You process it there, you send it back, and you try to deal with the result. But if you really want to use the data in production, you need it from one production step directly to the next production step. It has to run like a clockwork, and you don't have the time for latency or for server downtime or any other issue. And that's where we came up with the idea of inline AI processing. You mentioned it in the title of today's episode, and which means you are connecting AI directly to the data stream of your machines. There is no server, there is no additional node. There is AI which is integrated into the data stream. You don't have to change your OT IT system. You just attach a small field device, and that field device we providing is called EdgeBrain. And EdgeBrain is what we think is a new paradigm of integrating AI, which means this is a device which literally lives in the data stream, not in the basement, in a server room, or in the cloud. You have it directly in the data stream of your machines.
Yeah, I'm going to ask you what this EdgeBrain is going to be about, but before I want to understand. So, if in my production line I have, let's say there's 10 different steps, and the specific solution that you are being asked for is a problem that turns out to be between 3 and 4. So maybe this number 3 is the potential problem, which maybe you have to do. We discussed it at the end. I think you do a service consulting as well. So let's say that is known to your customer and to you. Then you're going to put in a solution in between 3 and 4, if I understand. Now, if at the same time there is another potential problem between step 9 and 10, then you would put in another potential solution between step 9 and 10, which is, in principle, from a software perspective, model perspective, different, but maybe from what you call EdgeBrain, it's the same approach.
Exactly.
Okay, very good. Then tell us, is this EdgeBrain something, right? Is it a device that you would use in those different instances? How does it look like? What is it?
It's a small device. It weighs about 300 grams. It fits in the palm of your hand, and it has industrial grade, which means it has IP67 security.
Right, 67 stands for, I believe, what is it? You recall?
Very ruggedized design. It stands for tolerating high temperature tolerances, humidity.
Humidity, right? Yeah, I recall. Okay, very good.
Yeah, vibration dust, rough industrial environment.
Yeah, very good. Right. And that has certain I/O. There's, I don't know, what goes in and what goes out, which typically is being used in a production line.
So we have two methods of connecting EdgeBrain. One USB-C interface or two USB-C interfaces for very high level or very new sensors. And we got an industrial Ethernet connection. And with that industrial Ethernet connection, we can connect it to every standard switch, bridge, whatsoever, what is present in industry. So you don't need a whole bunch of new devices. You need standard components plus EdgeBrain to integrate it into your machine park.
I recall, yeah. I come from that type of industry many, many years ago, but a company providing the different types of industrial Ethernet, Profinet, EtherCAT, et cetera, et cetera, et cetera. I think those are the ones that you're referring to, right?
Exactly.
Okay, very good. And I do recall that there are companies providing those exactly also on a FPGA. So may I assume that your FPGA solution is then included in your EdgeBrain solution?
Yes, EdgeBrain runs completely on FPGA.
Very good. I understand all of that, and I'm sure that our listeners are with us as well. And as I suggested, with the example of the solution in between 3 and 4 or in between 9 and 10, potentially what then runs on the FPGA between 3 and 4 is maybe a different model or the solution, the software, than what runs on the same EdgeBrain between number 9 and 10.
Exactly. That's the big advantage of the FPGA. It's completely free configurable, and you can also exchange it, reconfigure it to fit your needs.
Very good. So what do I want to know more than? What do we want to know more? Let's see. We just talked about, well, that was my assumption, but I've seen that you provide these integration services as well. And I was assuming, just out of my experience speaking, so I was assuming that your customer, your potential customer, and yourself know about this potential problem of production stage 3. But from my experience, you first need to find out. And the typical thing is that if we stay with this example of the 10 stages, you do not always know from the beginning. If something comes out at, let's say, stage 10 is the end of line quality, and there is a certain number, whatever, that can go out, but you don't want that to happen, and you then need to go back and find where did this problem come from. Not necessarily number 9; it could have been number 1 already. Now, maybe you tell us what if that is the kind of thing you do as well. So you need to, if the potential customer comes to you, you need to first find out what it is that they want. Maybe they know their problem, but maybe they do not know their problem. Is it something that you helped him with?
That's actually our first step. So we always approach the customer with our package called Smart Integration. And Smart Integration is some kind of phase analysis. What is there? So what kind of machines do we have? What kind of protocols? What kind of data is already there? Where can we start? And the next step is, okay, when we know where to start, where is the potential? Where is the highest potential to lift with AI? That's the second step in our analysis. And then the third step is that we are working together with the customer to draft a roadmap. And we always try to join the customer in the whole journey of integration. We are not a company selling one or two products and putting everything else on some kind of repository and leave the customer alone. So what we are doing is we know that a lot of companies, they are collecting a lot of data, and there is always this bottleneck on the one hand to analyze the data, and on the other hand to know what can be done with AI. And that is exactly where we are stepping in the first attempt to help the customer analyze the current situation, see potential or see the highest potential, and go in the direction where the highest potential lies.
Okay, yeah. So I think what you are saying indirectly is that, I mean, potentially you could imagine as this wonderful device that you present to us that you can keep in the palm of your hand, I believe, your EdgeBrain, that you could sell it kind of off the shelf, but you could possibly sell this piece of hardware off the shelf, but at least what goes in it, and that's what I want to talk about a little bit as well, you don't know from the beginning. So, I mean, the development, and maybe that's a question to you as well, is that are we ever going to be there in 10 years or before that we're going to say not only can this piece of hardware, I can sell it, there's a certain amount of dollars or euros that goes with it, but could at some point in time also be the solution that you put on it so general that it can, take care of whatever potential problem? Or do you say, well, it makes more sense to first understand the use case and the problem and to make a specific solution to put on the EdgeBrain?
You can use it also for generic problems like we see today: image analysis, time series analysis. These are more or less generic problems which can be dealt with EdgeBrain. On the other hand is that you have, when we go back to the assumption that we have a production line with 10 steps, and you say, okay, I integrated EdgeBrain, now my production line runs, it's intelligent, I can save costs, I have a higher quality, and at some point in the future, you exchange one step in a production line, you buy a new machine.
Sounds like a normal thing happening, right? Yeah. And then what happens? Yeah.
What happens then? It happens that the data stream you use before changes. And that's one point where you need to adapt the solution, which means the AI algorithm, the input-output of EdgeBrain, for example. And here we have the advantage that, as I said before, the device is completely reconfigurable, which means we just needed to configure it to the new situation, collect some data, retrain the AI model, roll it out, update the device, and that can all be done remotely. And you're back in the game.
Yeah, very good. So this is typically what you would call drift, maybe, I guess, because of many different reasons, or is drift another subset of the situation you just talked about?
Well, drift, so if you replace one part in your production line, I wouldn't call it drift because you have an instant change in the data stream.
Yeah, right. Okay. Yeah, that's a bigger thing than drift, right? Is drift then smaller, things more slowly happening? And do you provide for that? I mean, do you check drift? When does drift happen? And are you then involved, or does the customers call you and say, suddenly we get more of these whatever false alarms, and then you come in and you check, or how does that work?
Basically, you can have multiple sources of drift. Either your raw materials change, or the quality of the raw materials change slightly because you changed the vendor for some reason, the sensors are getting older, which means they produce different data or slightly different data than before. And of course, the production line itself gets older, which means we have some wear, which also plays a role.
Production environment, maybe. Yeah, humidity, temperature, you already talked about.
Yeah, actually, it is a problem. If you think back 20 years ago, you had, especially in the wintertime, we had completely different temperatures than nowadays. And these parameters all contribute to the drift. What we can do, we of course we provide our AI with, or our systems with, logging capacity, which means the customer has the logging, and we can then also detect drift in the system.
Where does the logging sit? Where do you save your logging data?
In that case, we need to communicate with the host system.
Right, which then goes through the industrial Ethernet or the USB connectivity? Or?
Yeah, we can have it both ways, either to the industrial Ethernet or to the USB connectivity. We don't need to connect to a cloud, so it can all stay on the customer's premise. But when it comes to analyzing the drift and retraining or reconfiguring the device, retraining the model, we are always there for our customers. So we provide a service that we are analyzing the drift, reconfiguring, or checking the system on site, because sometimes you just have a sensor which is broken and which needs to be replaced. That's of course a service we are offering for our customers.
Okay, very good. Let's talk a little bit about the solutions, the software, the models, whatever you're going to tell us that you call them, and maybe also the development environment that you use for it. So what is it that you use? I mean, I think you started saying at least that you started as, developing AI algorithms. Where are you today? What is it that you are using? You use whatever is available, open source. You still do develop your own algorithms. You own your own IP. You have whatever license agreements with third parties. Is that something you can talk about? Is it something that the customers want to know in detail? What is inside the solution that you sell to them?
When we talk about the AI models, we use the standard frameworks like TensorFlow, PyTorch, ONNX. Our models are designed in a way that they can run bare metal. So you can easily put them into a C++ environment and run the model. That's not a big problem. The IP we have in-house is the training of the models. So I think that's not a big secret. You're using a teacher-student approach, which means we have a big AI model, which adds a lot of variance to the data, to the training process. And we have a smaller student model. And with that approach, we train the model for the customer. We can train the model for the customer and provide then a very small, efficient, and robust model for the customer.
Mm-hmm. Now, is that a teacher model? Is that, a foundation model? Is that a model that has been, received or updated with industrial information, general industrial, which is not a big topic that we have in our industry, until the point where you are then training it with exactly, we talked about step 1 to 9 of our production line. So maybe it needs to see all the specific data in that line, or at least the data which is before where you're going to put it, or how does it work?
The teacher model is, you can call it a foundation model. That has been pre-trained with industrial data. And what we're also using very often is synthetic data. And we made very good experiences by using synthetic data, especially when it comes to outliers, disturbances, and we feeding it into our teacher model, train the student model with that, and end up with having a more reliable model than in the case we are just using real world data. Because in the real world data, you hardly have this kind of anomalies or
right. That's the problem. Yeah. If you work in an environment that has a very high level of quality already, so to say, so you have a small number of outliers, right? It's a very interesting topic, this synthetic, if I may ask just one more question, because in the past, my brain had always a problem with how can it be? Why are we using, in general, synthetic data? I mean, we have real live data. We have real live environments. And I recall, it must have been like, I don't know, 5-6 years ago. And the first time I understood is when it was about autonomous driving. So we didn't want to receive real live data from a child crossing the street. And I thought, oh, okay, that's a great use case. Now I understand why we do it. But the reason you do it is almost like, completely different. So I still want to understand where you get the synthetic or how you produce the synthetic data. Let's say it has your solution, one of the input values is, let's stay with the temperature. And there's probably many other ones as well. And they go into a model. Now, how do you then produce this synthetic? You produce the outliers, I assume, because maybe you don't have enough outliers. So are they related to the very specific use case that you provide a solution for, or?
As I told you, it is a foundation model which has been trained with a lot of data we acquired in the past, not customer data. So and when we start working together with a customer, it is, as I said, we really want to know the problem of the customer, and we want to understand the customer, and that is where we need to collect some data, and from that data, we are trying to reproduce the outliers we are seeing statistically. So when it goes back to temperature, there are a lot of physical models to model some temperature-dependent anomalies.
Okay, and they exist quasi. They are theoretical models that have been produced, kind of, and you can use them in your environment.
Exactly, yes.
Okay, good. Yeah, I mean, one outlier I can imagine, and but again, speaking from experiences, suddenly you get a zero value, which means probably your sensor is broken. And if that never happens, or if it's almost never happens, but you could already, and maybe your model takes care of that. Your theoretical model takes care of, okay, not only the +10, plus -10, whatever, but also put in a zero for, which means sensor broken.
Yeah, that is our experience. We are kind of infusing into the training process. That, okay, we see where the customer data is, but we also include what could be in the worst case. The worst case is, of course, sensor is broken, or sensor is producing some unreliable data.
Very good. Coming to a close here, what for you means European sovereignty?
European sovereignty means that we need to find a way to equip our industrial base, the heart of our industry, with AI, which is not dependent from third countries. So we need to establish in our base local AI capacities, and we need to develop this with a European approach. And if you think about that, what is a European approach? It's about efficiency. Europe has always been strong when it comes to efficiency, because we do not have this kind of huge natural resources other countries have. We always needed to be efficient, and that is why industrial use cases are so, how should I say, these are kind of the best cases for proving our capability of being efficient, because you don't need some huge AI model server farm to deal with a specific problem. What you need is a specific solution fitting to your problem, and not some big generic solution which might fit to your problem. And yeah, I think that is where it comes together. Europe is very strong in AI research, and Europe is also very strong in precision. And that is what we need to bring together, bringing together AI and European precision.
Let's try to get I'm going to ask you for a rough idea on a number. If we look at because you have now been working for the time that you have, you'll tell us later on, with all these production environments. So let's say that if we look at the production environment of, let's say before you and others were putting AI inside. What would you say is a typical number of, let's say, Europeanness in that production line? So you look at the hardware, you look at the boxes, maybe you look at, the operating systems, you look at we talked about industrial communication, maybe there is a number there. I don't know. Maybe you tell us, maybe that's 70, 80, 90, maybe it's way lower, whatever you think that number is. And then you come with your solution called EdgeBrain, and that is a piece of hardware. There's an FPGA. We already heard we have models. Where do you think that part of the total solution is going to be also? Where is it, by you or by others? Can that grow to a total of towards the 100%, or is that going to be way less than that?
I'm very confident that with solutions like EdgeBrain, if we had in the past about, our industries we have old players which are very experienced, which produce very good products, and they're also producing very high quality. But on the other hand, and I think that is the real gain, is how to make our processes more robust in a way that we can deal with more variants of the raw material which comes in, and to optimize our processes in a way that we have a higher quality, even if I have more variants when in the raw materials which goes into my production line. And I think it is very difficult to say now we have 90% efficiency. We already have in Europe a very high number of efficiency. But what we can do, we can make our production lines, our industry more robust to some kind of variance. And I think in that robustness lies a huge potential in, on the one side, decreasing the cost for your raw materials, and on the other side, increasing the quality. You see this, if you would call it like that, I think we can lift productivity with such solutions like EdgeBrain, which are small and smart, by about 30 to 40%. I'm very confident.
Okay, so maybe that is already an answer to my final question before I'm going to ask you a little bit more about your team. I was going to ask you how then a solution like EdgeBrain is going to change the market. Is that a potential answer? You say there's a number X, I think you say 30, 40, that we can, with that kind of solution, increase our productivity, or call it, I don't know, OEE, overall equipment efficiency of our production lines?
I think solutions like EdgeBrain will change the market in a way that it makes integrating AI much easier. Once configured, it is a plug-and-play device. And if you equip one of your production lines with EdgeBrain, you don't have to reconfigure the whole system if you use it in a second site. So if you have the same production line in multiple sites, no problem. Once configured, it's real plug and play. So I think we are entering here a whole new market, lifting AI from a pure software to an attachable device.
Now, Robert and I talked about, and it was, well, in all modesty, it was me saying maybe 5 years ago that I thought 80% of the processor cycles were going to be unembedded. And your approach seems to be moving in the same direction now. Why then is US, mainly big tech, planning billions, trillions of dollars for huge cloud capacity? Is that still, not expecting you to say that's good or bad, or they should or they shouldn't, but from your understanding, is that still a useful thing as long as they want to further develop models? So as far as training of models is concerned, models that maybe you could potentially be using as well if they are open source? Or would you say, no, the market is moving towards solutions like EdgeBrain, so embedded solutions, and they're going to be small and they sit locally? How do you see those, developments?
I think we have two different fields here. On the one hand, you need these huge AI factories to train these huge generic models, which can be used for a lot of purposes, like models like ChatGPT or Gemini. But I think that is a completely different approach. If I need some kind of general purpose model because I want to analyze my documents whatsoever, I need this kind of big models. But if I would like to optimize my production, my my industrial core, I don't want to connect to any cloud server, something like that. And I need a highly specialized solution. And I think what was the or what is the SPS now in most cases can be replaced by an intelligent system which leverages all the advantages of AI, stays on site, does not communicate any of your business secret outside, and will enhance your production quality.
What we call the SPS, is what we call the PLC, right? In English terms.
PLC.
That's okay. Very good. Let's come to a close. Tell us a little bit more about your team. Is it just you? Are there other people working together with you? Where are you based? Are you looking to extend? Are you maybe looking for having other people join? And if so, what should they bring? What is the type of activities that you and your colleagues take care of?
So at the moment, I got 2 hardware developers at hand and a software developer. There, of course, is my financial background. CFO is managing all the finance issues. And yeah, currently we'd like to expand. So the device is FPGA based. I'm looking for FPGA developers, of course, and good software engineers. And as I told you before, our vision is to bring together precision and the power of AI. And we are based in Nuremberg, which is basically the city of Albrecht Dürer. And Dürer stands for bringing together art and mathematics. So I think this is the best place for a company, bringing together mathematics or precision and the power of AI and deliver it to industry.
That's a great closure, Andreas. I'm not going to add anything else there. Thank you very much. Thank you very much for having shared with us your approach to providing industrial AI solutions, inline AI for real industrial systems. We wish you good luck. I was just thinking, I think it was just a week or two ago when Robert talked about, I think there's this huge potential prize of the European Union, right? I'm not sure that you're interested in that, with or without. I wish you all the luck. I think your direction you're taking is very interesting. Thank you very much.
Thank you for having me.
Thank you. Bye-bye.
Bye.